All right. One. We had Friday was it was stuff. Friday was lots of stuff. So here's the deal. If I remember right, we started into 4-5. We did not finish 4-5, did we? Okay. So we didn't finish it. And yet, we have a plan book assignment. Because things were so chaotic, I forgot to ever change it. I forgot to ever text everyone and say, don't do it. So now the question is, who did it for real?
I did some of the part.
Okay. The last part was literally the exact same thing, except you just find it on a calculator. Right? But we didn't actually get there. So here's what we're going to do. We shall not do daily quiz today. That assignment is what you should have done for tomorrow. Who said that?
Yeah, who said that? You. Boy.
Okay. Instead, what we're doing today, we're going to finish off 4-5. And then we got to take a trip down memory lane before we can touch 4-6. Because it turns out the whole lot of you did not work incessantly with simplified radicals in geometry.
Love those.
So we might have to do be it the review. So yeah, not getting that changed. Well, last week was a heck of a roller coaster. Like, I don't know what it was for you, but oof. There was 2 nights of Midnight Plus, Grade-a-thon, midterms. Oh yeah, conferences. Those are supposed to be done at 7:30. I didn't get out of here till about 9. They were parents I wanted to talk to though, so.
That's good.
Like it was nonstop chaos, and then Saturday was a 20-hour long adventure of Geekathon. So I just never sent out the text to say, "Hey, we didn't finish. Have fun. No homework this weekend." Oops. So if you did not do it, don't feel bad because I never sent the thing. However, don't not do homework just because I don't send something out on Remind. I had to chew out pre-calc about that. Yep, website, right? All of our solutions are there. The link to our playlist is there. The plan book is on there, and the join code for plan book is there. If I don't send a thing, you still have access to the thing. If I forget to update the links on plan book, just poke the Google Drive and the video because they're right there instead. You'll always have access to it. Now, what I'm worried about is for 3-4 days now, no one bothered to ask. No one bothered to ask and say, hey, we didn't actually finish 4-5. Are we supposed to do this? That's a little bothersome. Just a quick text and say, hey, do I do this or not? That's it. That's all you have to do. So we'll finish off 4-5 real quick, and then we're going to move into a review of radicals. Yes,
What day is the test?
tomorrow. Because we did Monday. No, Monday was FUBAR. We did Tuesday, Wednesday, Thursday, Friday. Today. That's 5 days. Tomorrow's quiz. Okay. It's also a nice clean break before we do 4-6. So, y'all got your stuff out? Ready to roll?
Yeah.
Okay. Then, no daily quiz. Bum, 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 bum. First, I want to see what you remember for those of you who claim you did your homework. We only had one example left. So we got through how do I factor both GCF and regular to solve, and how do I solve by graphing. Okay, those three. Show me you remember what we were doing. This is super important too, because if you can't solve by factoring, it kind of craps out the next month. You have to be able to factor. That's why it was in Algebra 1. Okay, we're just reviewing it right quick before we start adding in a new dimension. Do you remember? How about that factoring decision tree? Y'all remember that? is the thing? There it is. In that big honkin' Google Drive folder of ours with all of our shared stuff, there is the factoring decision tree. Stage is not even 1, 0. Make sure you get everything on one side. Set an equal to 0. Stage 2, you look for a greatest common factor. Stage 3, are A and C perfect squares? If they are, it's going to have 95% of the time, it's going to have one of these special forms, either a binomial squared or a difference of squares. If not, you either get to do the easy peasy, what factors of C add up to B? That's when your A coefficient is 1. Or you got to do the full AC method. But it's all right there, set up as a decision tree. You've all seen actual decision trees before, right? Like, is it broken? Yes or no? Did you do it? Yes or no? Can you get away with it? Yes or no? Not your fault. Kind of thing. Anyone? No? All right. So it's like that, but for factoring. So round 1 says I need to get everything on one side equal to 0. Little Taco Bell after party there, right? Huh?
Yes.
Huh? Okay. Then, greatest common factor. See, if I take a 2x out of here, I'm left with a x minus 4. This is now a thing times a thing. It has been factored. Now, if that whatever is left over, say this was x squared minus 4, well, then I would keep going. But in this case, I can't make x minus 4 any more clean than that. So you set both of these equal to 0. If 2x equals 0, then x must be 0. If x minus 4 equals 0, add 4 to the other side, get 4. That's it. Nice and quick. Now, I know this one says by tables. Remember we said never do that? Table's bad. That's where it's like you look at the table and you see it goes from negative to positive somewhere between 3 and 4. Okay, so set your table to start at 3 and go by tenths. All right, it happens somewhere between 3.2 and 3.3. Set your table to start at 3.2 and go by hundredths. And then you just keep narrowing in and in and in and in, and it's a pain. I would rather just, in this case, factor. Everything's on one side. Cool. Is there a greatest common factor? No. Are A and C both perfect squares? What's a perfect square? Not 2. 1, 4, 9, 16, 25, 36, 49, 64, 80, 100, 121, 150. Okay. So it is not. And luckily, A equals 1, which means I just need to look at what factors of 24 add up to negative 11. That's important. Now, I could just put x and x here and then list out all the factors of 24. Well, it's 1 and 24, it's 2 and 12, it's 3 and 8, 4 and 6, and on and on. and then you guess and check which one's going to work. You could do that, or if you got the mental mojo, you just go for it and say it's -3, -8. But you're not done. You have to set those equal to 0 and solve. And then finally, we had solve by graphing. And that one, get over there. There you go. Good job. I go to y equals, Claire. Type this, but you have everything on one side. So you'll have 5x squared minus 7x. And when I subtract 3 over, we'll have -11. Now in this case, 5 times -11, remember AC method? 5 times -11 is -55. What factors of -55 add up to -7? None. That's like, what, 7/5? Half that, 7/10. That's like, so it can be 11, 11/5, 7/5, 49 tenths, 49 hundredths by 20, 220, 49, 71. Now I'm betting most of us aren't going to come up with 7/10 plus square root of 71 over 10 and 7/10 minus square root of 71 over 10. Okay. So what we do for now until Thursday is I look at my graph of A and I say, well, those places, how do I find that 0, that solution? Remember that calculate occurs in 2 different places. There's stat calculate, that'll find stuff in your lists from your table. If I want to find something on my graph, I use this top row. So I'm going to find a 0, and I'm not sure exactly where it is, but I know it's between -2 and 0. As long as my arrows are pointing in, we're good. So I'm going to have to say approximately, right? We'll say x is approximately -0.940. So I'll just cut it off there and do it again. Now remember, you can move Blinky around manually like this. As long as it's on the left and then on the right, I mean, I don't even have to say that. I could just say 6. Right? As long as those arrows are pointing in at where the 0 occurs, you're okay. I don't care about the guess. And then we'll have and 2.340. So we're just going to have to ballpark it like that. Okay? Now, we ballpark it by calculating it, not just, about -1. You don't just wing it like that. You actually go calculate the 0. So, that is where we left off last week. So the last thing that we have, oh, that looks fun in inverted colors, the neon blue frog. So a long time ago, some famous white dead dude made a story, and then we had to keep reading it in high school. Celebrated jumping frog of Calaveras County. Frog jumping competitions are apparently popular. I don't know that I believe that statement. Down south, they will actually do frog jumping competitions. Like, maybe not so much around here, but I grew up northeast North Dakota, and literally, I used to work at and then live at Turtle River State Park. We used to actually have turtle racing.
That sounds awesome.
Like, you would get turtles, and everyone would like paint a number on the back of their turtle, and you would just go. And everyone would yell at them, and they didn't listen. So
Seen the cheese roll in the UK?
the cheese roll.
Yeah, it's like a big hunk of cheese roll.
So that's how I grew up. But apparently, frog jumping is a thing. So they give you the equation. Yay. We have the graph, although it's just kind of sketched on there. It's not really meh. The graph shows the function modeling the height. X is distance. And what would h or the y1 be? Is it going to be height? Yeah. I mean, it looks reasonable, right? So, how far did the frog jump? How high did it jump? What's a reasonable domain and range? How do I find all this stuff? Like, what features are they asking for? Okay, how high did it jump? This is going to be, this is your horizontal distance and then your vertical distance for every x and y. So if they're asking how high did the frog jump, they're asking for the vertex, right? Okay, what about how far did the frog jump? What are we trying to... Okay, you notice how it doesn't have a y-intercept on there? There's no constant. So if I plug in 0 for x, I get 0 for y. So it does actually start right here at 0, 0. So I just need to know where this thing lands. Well, that's exactly what we're trying to find, a 0 of it. So, y'all got a calculator on hand?
I do, actually.
Go! Plug it in, see if you can find your vertex and the 0. Now, I don't have to. Right now, could I factor out a negative 0.029x? Greatest common factor. I could use that to find my zeros. In fact, I'm going to do that. I'm going to take 0.59 divided by negative 0.029. You probably don't want to be tracing when you do that. 0.59 divided by negative 0.02. There you go. X minus 20.345. Okay. I just factored out because I see that it's just like that 2x squared minus 8x business. I just factored out the negative 0.029, which tells me my zeros are at 0 and 20.345. I did it that way. Could you type it in instead? Yeah. Negative 0.029. Oh, wait. X squared. All right. Forgot that there was other stuff here. Plus 0.59x. There we go. Now, if I just hit graph right now, I don't see everything. Also, remember x is horizontal distance. Does it make sense for me to say, here you go, frog, jump? And then he jumps straight backwards. I mean, they might in real life, but... So I'm going to change my window to say, let's go from 0 to... How far do you think a frog can jump? I don't know. I'm just winging it. There you go. There goes Froggy. And I can calculate my 0 that appears to be between there and there. As long as I have the 0 is somewhere between those two arrows, oh, look at that, 20.345. Okay, so you can do it by a factoring in this case because there wasn't a constant term at the end, or you can just dump it in your calculator, go find your 0. So Froggy goes 20.345. Okay, how high did the frog jump? Well, I can do the whole negative b over 2a business, right? I have an equation.
Yep.
Negative b over 2a, plug it in, find out what the y part is. Or, since I'm already here, second, calculate. I'm going to go find a maximum somewhere between 1 and 25. Okay, doesn't matter as long as you're pointing in at that vertex. Now, be smart. What is x and y? Distance and height. I like that. Distance and height. So if this point right here is about 10 point what? 172 and 3.0008. I'm just going to say 3 because that's out to 3 places. Well, actually, it'd be 3.001, but whatever, close enough. Now, I want you to think about this. What is this in real world context? Y'all see the tiles? Those are 12 inches. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 17, 18, 19, 20. Literally, Maria's sitting right on top of 20. Okay? So, that is, and then 3 feet tall. That's me putting a frog right here, and it goes whoop, and lands right under her chair. And it gets about as tall as Brooke's chin. Whoop. That's a frog right there. Now, you don't see those too much around this area. Around here, you're going to see little frogs, right? You'll see toads. But if you're talking about down south, some of those frogs, its body is the size of my fist. That's a big honking frog, okay? Oh, answer part B. How high did it jump?
10 feet, 3 inches.
No.
No, 3 feet.
How high did it jump? Okay. Horizontal and vertical. Distance and height. About 3 feet. Okay, now pay attention to part C. It's not enough to just be able to do equation stuff. Can you answer what it means? Reasonable domain and range. Remember, domain was what? X's. So for my domain, the X's, what is the least amount of X's to the greatest amount of X's for this problem? Now, if I was talking about the function itself, well, it's a parabola, all real numbers. But because we're talking about reasonable domain, I want you to think about that on this picture. Is the frog going to jump from me to Maria and then just like, I don't know, shadow cat phase its way through the floor and just start tunneling its way down to the Philippines? Okay. It doesn't make sense for the frog to keep going. So that's why we say from 0 to 20 point whatever that was. Okay. And we'll use brackets because it equals 0 and it equals 20 point, what was it, 3, 4, 5? What about the range? Range was the y's. Y's represented what in the problem? Height. So what's the lowest the frog ever goes? The highest the frog ever goes. There you go. Okay? Yeah.
Why wouldn't we use the parentheses or the?
Parenthesis means it doesn't equal this value.
Okay.
Like, remember, remember I do like an open circle to say it's not touching 3? I'm not touching you, I'm not touching you, I'm not touching. Since it actually gets to 3, I use a bracket to say it equals 3. Okay. Now, if I was going to go old school, I could also write this as a compound inequality. I could write this as a compound inequality. Okay. Interval notation is just a smoother way to write it. Okay. So, I'm going to do the same thing, except now we're going to talk about the foosball.
Okay.
You kick the soccer ball. Go poof. How high does it go? How far does it go? What's the domain and range? Same thing, except now it's a soccer ball instead of a frog. Although it'd be a little funnier if you kicked the frog. No? No. Football. We're the only arrogant country enough to say that our football is different football.
American football. It's better.
Do you know that movie, Mr. Scott?
What?
Movie, it was a kids movie, but they would take like animals like a frog or a snake and just throw them up and just
It's an actual football.
It was a movie. They did that. Like they took like a frog, like a live frog, and just glue it up into a balloon.
My zoom out doesn't do it. You don't have to do why.
It sounds familiar. No, I know what you're talking about.
I just can't remember his name.
It was one of the Shrek movies.
Yeah.
Shrek and Fiona did the thing, and then they're prancing along with balloons made out of like swamp bullfrogs. Yeah. Yeah. I really want brownies tomorrow. I'm thinking about making Caden go up there and do this. Come on, stay with us, Haas.
Enter. Yes. You should do even more than right.
Yeah, pre-calc are in their last one today.
Oh my god.
I have a feeling whatever you're watching, it does not involve kicking this particular soccer ball.
Involves lots of frog jumping.
We researched it. Actually, they have, like, look at this. They have like little leagues and they have like little special hats. Ripple, corrosion,
Man, dude,
wet
a
bat.
frog jumped 21 and a fifth. 21 feet.
They have the
All right.
record frog.
Let's do math now.
It was very interesting.
No. Yes.
How do you find this zero? Because it just keeps telling me no. Do I have to like go
Find what?
The X or
Okay, what are you trying to find?
how far the soccer ball travels?
Okay, so you want to find when it lands, right? So you need your window to go a little bit further. Not 50, go further. I don't know how far. Okay, hit graph. You just want to see if it hits. There you go. So this is called a zero. So if you second calculate a zero, it's asking for a left boundary. Is this on the left of the zero? Hit enter. Move Blinky over to the right. No, it's going to disappear off your screen. That's okay, as long as it's to the right of it. Okay, hit enter. See, aren't they pointing in at the zero? Okay, hit enter again. Skadoosh. There it is, 53 and a third.
I always thought it like had to be there, so I would always do it like here and there, and then it would confuse it.
Gotcha. No, as long as the X value is showing, it doesn't care about the Y's in terms of your selection. But if you wanted to, you could always hit window and you could expand it out so you can see further down.
Do we round it?
Since this is especially 53 and a third, right, 53 and a third.
Yeah, I have maximum, but don't I need the right one too? Each competitor's frog is allowed 3 hits. Second, calculate. 0.
And then put it to the left of the line. Right there.
See, now I just got images of like future news headlines. A couple of some teenagers from Spearfish, South Dakota, are imprisoned this weekend because
If you can break the record.
they broke into reptile gardens. Well, frogs where you come from are pretty big too, though, aren't they? Like fist size?
I never seen a frog.
Oh,
There are some.
like I thought from like Germany south, like that belt were big honking frogs. Oh, okay. Okay. My sister-in-law's in Tennessee, and she said she caught a frog like the size of a dinner plate in her backyard. So, thing's a mutant. All right. I come over here and I hit y equals, I start typing negative 0.03x squared plus 1.6x. Okay. Hey, I want to go back to something we've done before. Remember we had Zoom Fit? Zoom Fit is an option where the calculator is supposed to zoom into a window that makes sense for the relevant features. It doesn't always work. See, like here, I do see one of the zeros. I think I see the vertex. But do you see where it lands? No. So sometimes it works, sometimes it doesn't. I don't know, like 100. I have no idea how far that's going. 21 looked like it almost got the vertex. I'll just say 30 to be safe. There you go. So we calculate a maximum somewhere between 5 and 60. I don't care, as long as it's there. Be smarter than the calculator. What is that? 21 and a third, or 64 thirds? Now, if I said that I kicked the ball 64 thirds feet in the air.
It's actually meters.
Oh, it's meters.
That's a brownie.
That's not a mathematical error. That's like.
Just write it on the board real quick. We'll take it off.
Units are in meters.
Ah, crap.
Yeah. You know you want the brownies, so.
Yeah.
And pre-calc it's brownies. So you already have to make brownies. So just make it out of brownies.
All right.
Boom.
Mm,
Yeah, there you go.
that bothered me. Okay. So, if I say I kicked the ball 64 thirds meters in the air, okay, not many people are going to understand what you're doing, right? So, can I say approximately 21.333? All right. If I recognize that it's a third, can I just say 21 and a third? Okay. Right? This would have been perfect. Okay, the reason I'm thinking feet is because if it was a third of a foot, you could just say 21 foot 4 inches, right? A third of 12. So, oh well. And then I can also calculate a 0. All right. Allison had a good question about this. Said, if I have Blinky over here for my left boundary, it was kind of confusing to see Blinky go off-road like this. Right? Like, where is it? Well, it is over here. All the calculator cares about is that the x values that you're putting in are present. It doesn't actually care about the y values. So, as long as it's between those two, you're good. Okay? That goes double for the vertex. What if my window only went to 20? Can I see where the vertex is going to be? Do I have the x values that it's going to be between? I can still calculate my maximum between 2 and 50. As long as it's between there, it's still going to tell me. Quiet. Sorry. So, Mr. Palmer, how far did the soccer ball travel? Nope.
Might take me a little bit.
Maybe there's a difference between I can follow what you're doing and I can do it myself. Make sure you're actually doing what we're doing in class, not just writing something down on a paper. Okay? So what was it, 21 and change? Okay, the height was about 21 and 1/3 meters. The distance, how far did it go? Okay. Reasonable domain and range is just 0 to those, right? because again, the ball isn't going to, you're not just going to thump and then the ball starts tunneling. Okay? Not going to work that way. So, that was just one example of a word problem that involved a quadratic. You can have different kinds. I want to give you a little bit of time to argue about this one. Because if you say that you did the homework, then you probably goofed on the problem like this in your homework. Argue with your neighbors and see if you can't figure out how to write the quadratic.
That'd be incorrect.
So what we're supposed to be arguing about? To where it all started.
I'm going to need this in case I have to throw it at someone again.
16, 25, so 16 plus 16 plus 3.
I have to research some cheese around Cupertino. That is so much fun.
Do the problem.
This doesn't.
This doesn't sound anything like the problem.
We were just talking about how nice the painting looked.
That's great. Do the problem.
See? Except I definitely did that homework. Okay, and then. Well, now you have to figure out how to write it. So you do.
Oh, I guess. No, it's actually.
How? Why?
What does it represents the framing material for
James, what do you know about the problem?
3, 4, not 2,
16 times because it's how wide do you frame? So that's what you're trying to find.
because it would equal that, so you subtract it and equals 0.
Right? You have to figure out how to make this equation to get the answer. So like let's say
No, Wednesday.
it's just asking them to frame. So you have
What do you say?
to.
How wide
I
would
see
it So I'm at 24 plus 1. There's only 80 issues.
When in doubt, draw it out. Right? It says that you're going to have the same width all the way around for a frame. So this area I have the green stuff is 276. How do I say it's the same width all the way around if I don't know what the width is? We put x for an unknown. So that means this is x, this is x, this is x, this is x. So if it was 24 inches wide, and I went x inches this way and x inches this way, how wide is the frame? Plus 2x. Right? 24 inches plus an x plus an x. So how tall is it? Okay. So that's going to get me the area of the frame. I don't want, or the frame including the picture. But I don't want to include the picture. So we know that the area of any rectangle is length by width. That's the entire thing. But I don't care about that thing. I care about that minus the inside. We called these they're called partial area problems, or we always called them the donut problems, right? Have the whole circle, take out the donut hole. You take the entire thing and you subtract the part you don't care about. I don't care about the 24 by 16. That makes sense? Like area of the entire thing minus the area of the painting itself will get me the frame. And it specifically tells me that that frame is 276 square inches. Area of the whole thing minus the area I don't care about is the frame. This is a very, very, very common application of quadratics. Like guaranteed to see on an ACT common. You will see this. Okay? Now, if I'm trying to solve for x, I want everything on one side, right? So if you wanted to go all the way, you could FOIL, remember? 24 by 16 is what? 246, 120, 360, 384? 384 plus 48x plus 32x plus 4x squared minus 384. And then I'll subtract that over. Minus 276 is 0. Combine like terms. Make it a little bit cleaner. 4x squared plus, what's that, 50, 80? X minus 276. Hey, I'm solving this. It's a quadratic. Could I divide by 4? Factor that out? So what's that? 50, 76, 69? Are there factors of negative 69 that add up to 20? So then x equals negative 23 and 3. Okay. That's one way I could do this. Right here at purple, I could have taken that entire thing right there and said 24 plus 2x in parentheses, 16 plus 2x in parentheses, minus whatever 24 times 16 is, minus 276. If I jam the whole thing into y1 and look at the graph, well, we're missing part of the graph. Zoom fit. So close. That window's ridiculous. Zoom standard. Oh, well, I don't see the rest of the parabola, but do I see the 0? Well, maybe not quite. Can I see the vertex yet? Jerk. There we go. Okay, now I'm trying to find my zeros. Isn't this going to be negative 23 and 3?
Yeah.
I didn't have to actually simplify this. I was able to type it one shot, leave it ugly. My calculator will still graph it. Can I have a frame that's negative 23 inches wide?
No.
Okay. It was positive and negative for the factors, the zeros, when you set them each equal to 0. Okay? So, moral of the story, if I have an equation, I know how to solve it now. I can either factor it or I can dump it in my calculator. If it says by factoring, you need the work to back it up. If it doesn't say by factoring, go ahead, have fun. Press buttons. So, that is where we left off. Now let's see who remembers.
So 500B. I don't know.
Okay, so we got to do a little bit of review before we get into 4-6. Put it away. For the first time in years, let you know, my White 3 class had all of their stuff taken away. They have to sign out to go to the bathroom. They don't get their phones. They don't get anything because they showed me that I can't treat them like adults. Don't make me do the same with you. Now, we're going to have to go a little off-road here. Not in the book, because it's expected that you already know how to do all this. It's expected that you were doing this non-stop for the last 2 years. That might not be the case. So we're going to review, make sure that we know how to simplify radicals before we actually get into the stuff that involves radicals. Okay. First things we need, do we actually know our perfect squares through 20?
No.
I'm betting that most of us know them through 10. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. Who can keep going from there?
121, 144, 169.
196, 225, 256, 289, 324, 361, and 400. If you do not know those off the top of your head, I don't care how you have to do it. Go old school and flashcard it. Quizlet, Kahoot, I don't care. You need to know your perfect squares through 20. Starting next chapter and beyond, you need to know your perfect cubes through 10. Starting chapter 6, you need to know your perfect fourths through 5. And as many powers of 2 and 3 as you can get your hands on. You should know off the top of your head what 2 to the 5th is. Anyone? 32. Okay. At the very least, your generation should know the powers of 2 because y'all probably played that 2048 game. Right? Okay. So, if you do not know these off the top of your head, I suggest you have them written down on a piece of paper, on a note card, something like that, and you have it handy for the next 2 months. Now, normally I would say I'm just being facetious and look at the watches for dramatic effect, but I have my date on there, so I'm thinking about when we're actually going to finish up through chapter 6. Okay. Everyone got this? These are just the ones you should know off the top of your head. I would strongly recommend getting familiar at least with the numbers further than that. If I see the number 576, that rings a bell to me. 576, that's important. That's important. What is that? Oh, 24 squared. Okay? Because it's going to happen. We're going to run across those numbers a lot. Everyone good? Okay. There are 2 schools of thought to how to simplify radicals. The way that you're supposed to be familiar with is knowing what is the biggest perfect square that goes into this number. If you need to, on your calculator, 500. Well, what's a perfect square below 500? Okay. 400. Does 400 go into 500 evenly? Not even close, right? So what I would do from there is then go halfway, because the easiest that a simplified radical could be is perfect square comes out, square root of 2, right? Just cutting the number in half. So start at 250-ish. What's a perfect square right below 250? 225. Right? 15 squared? And then you work your way down the list. You say, does 225 go in there evenly? Nope. What about 196? Nope. Keep going. 169. Right? You go until you hit the biggest perfect square that goes in there. Because doesn't 25 go in here? I want the big dog. Okay. So I would rewrite this as the square root of 100 by 5. It's not just any two factors. I can't say 50 and 10. Because 50 and 10 aren't perfect squares. But since the square root of 100 is 10, I call that 10 root of 5. Okay? That's one school of thought. By that, I should be able to write, what's the largest perfect square that goes into 50? Okay? So I say 25 by 2. And since the square root of 25 is 5, 5 square root of 2. Biggest perfect square that goes into 32. Biggest perfect square that goes into 24. Why not 8? Okay. And I say, since the square root of 4 is 2, this is now 2 root of 6. Greatest perfect square that goes into 48. Or sorry, 48. 8. 4 by 2. And square root of 4 is 2. 2 root of 2. Hi.
Can't you simplify that to, like, split the 6 into 2 and 3?
Okay. Now, here's where we're heading into the other school of thought. If I were to call this 4 by 2 by 3, 4 is a perfect square. Are 2 or 3 perfect squares? So they stay in radical jail. Okay? The other school of thought, let's go back to this 500. Real old school. Who remembers factor trees? If I'm stuck, I am beyond stuck. I don't know what goes in here. I can say, well, I know that's 50 times 10. That's 25 by 2. That's 5 and 5. That's 2 and 5. Y'all remember your prime numbers? Didn't we just talk about this last week? Your prime numbers, if you don't know your prime numbers off the top of your head, I would recommend writing those as well. 2, 3, 5, 7, 11, 13, 17, 19, 20, 3, 29, 31, 37, 41, 43, 47. Okay. If you don't know your prime numbers through, I'd say 50, add that to your list of stuff to flashcard. Okay. If you were just going to stop at geometry, okay, you could probably get away with just calculators and decimals and guess and check. You're at Algebra 2 and beyond, you should know this stuff. Okay? It's called a prime factor tree. Not just factor tree, but prime factor tree. Because I write it as prime factorization. I say that 500 can be written as 2 by 2 by 5 by 5 by 5, because those are all prime factors. Remember, perfect squares are numbers that are something squared. Well, something squared is something times itself. What happens when I take 2 times 2? 2 squared, right? So the square root of 4 is 2 because 2 squared is 4. That means every time I see a pair of factors, you cross it out and 1 gets out. Right? Because 2 by 2 is 4, square root of 4 is 2. The way that we always looked at it back in my Algebra 1, we'd say it's radical jail. And whatever the index is right here, it's kind of like what level guard is guarding radical jail. It's a level 2 guard. You need 2 guys to bum rush the guard to get out of radical jail. But only one of you survives the attempt. Okay? Same thing's going to happen when we start hitting simplifying cubes and 4th roots and 5th roots and so on. Now we're going to need 3 or 4 or 5 factors to get past the guard. Everything that's outside parties with what's outside. Everyone who's lame and doesn't have a friend stays inside. Okay? It's still 10 root of 5, right? So whether I said 100 by 5, square root of 100 is 10, or whether I broke it all the way up like this, it's still going to work. So here they show us break it up by prime factors. Every time I get a pair of factors, you bring one out. Bring one out. Okay? So what's the biggest perfect square that goes into 48? 6 and 8 aren't perfect squares. Okay, I heard 4 goes in there. 4 times 12. But doesn't 4 also go into 12?
Yeah.
Could I recognize that on the fly and do this? Because whether I say a pair of 4s, 1 gets out, or whether I said 16 by 3, a 4 comes out, it didn't matter, right? You just keep breaking it up until there's no more perfect squares in radical jail. But you have to find what that perfect square is. And this is where we see whose multiplication facts are good. Or who's really fast with the calculator.
Is it 6 squared 5?
Which one?
216.
216? No. It's 6 squared is 6. But keep going. I would like you to finish off those 6 right there. It's not enough to just press the button on your calculator. If you can't do it, that is a big difference between you can do it and the calculator can do it. There are several of you in here who are rocking scientific calculators that will simplify radicals for you. Don't rely on it. Do it for real. Okay?
So I can find the answers on this. Obviously, it tells me. But
Yeah.
I'm just completely lost.
Okay. So, were you okay with breaking it up like this?
I don't know how you did that.
Okay. So I go down my perfect square list. 1,
I have
4.
all of them written down.
Okay.
I was just so
So,
confused
32.
how you guys were like.
I go to, that's the biggest perfect square under 32. Does it go into 32? Evenly. Do 32 divided by 25. Nah, doesn't work, right? What about 16? Yes. So I'll rewrite it like this. Not because 16 was a factor, but because it was a perfect square factor.
So you just kind of.
And since the square root of 16 is 4,
So is it this number divided by whatever the
Whatever perfect square goes in there.
Okay.
Yep. So since the square root of 16 is 4, 4 squared and 2.
That was confusing. Just because like there's two different rows and it took me forever.
The number and the number squared.
Yeah.
Or the
just,
number and its square root.
Yeah. That was.
So with this, I go to 160. Okay. Does 144 go into 162? Okay, it was 81, right? So we rewrite that as the square root of 81 times what? And since 81 is 9 squared, the square root of 81 is 9. 9 root of 2. Now the other way to do that, if you have no idea what's going on, and say, well, I know it's divisible by 2. Well, I know that's divisible by 9. Well, I know that's 3 and 3. So since I can rewrite this as 2 by 3 by 3 by 3 by 3, 3 by 3 is 9. So that means the square root of 9 is 3. Every time you see a pair, you cancel it out and bring one out. See how there's a pair of 3's outside? And a 2 inside. Okay. This is how we first introduce it, yep. But after geometry, we should have been doing this more because we just use them so often. I know. Okay. But don't feel bad because they don't remember it either because our teachers aren't making them do it. So, you got to break these up.
Yeah, I knew the calculator.
Yeah, I know it'll just do it for you, but you got to know how to do them for real.
I could have just
Okay.
gone all the way through.
Oh, you would just be beyond screwed when we hit chapter 5 and 6. So.
If that checks out to you, I don't know if that actually makes sense to you, but.
That makes sense.
Okay.
Oh, yeah, cause, yeah, you're not trying
You
to
get
get
it now?
216, yeah.
Okay.
Under math, you have an option
I just did multiplication.
for the prime factorization of a thing.
When I took out the two of the twos, I did 2 times 2 on the outside.
It'll do it for you.
Yeah.
2 times 2 times 3 times 3 times 3. You're still going to simplify the radical, aren't you?
Yeah.
I actually use that a lot with larger numbers. Yo!
So I think I did this one right, maybe? I identified
Yes.
that this was 6 times 6, and then
Yeah.
just left the 6 out. I didn't have to show that word.
Well, because it's the square root of 36 is 6. Yeah, that's it. That's fine.
Very good, yes.
Yo!
Is this right?
No. Okay, so you got here, the square root of 9 is 3.
Oh, yeah, so that should be
And a pair of 3's, 1 gets out.
Yeah, so that should be.
There you go.
So then 3 times 3.
He has them.
Okay, so for these ones, when there's, when we multiply 11 by 2, do we just make it to the square root of 22?
Yes.
Okay. And then what do we do if there's 2 numbers on the bottom? Would I just multiply
We're
by...
getting there, kid. Chill. Jeez. Okay. I've got options. Option 1. I have no idea what goes in here, but I'm going to break it up by prime factors. And I get 2 by 3 by 3 by 3 by 3. Option 2. I know the biggest perfect square that goes in there is 81. whether I take a pair of 3's, 1 gets out. A pair of 3's, 1 gets out. Versus the square root of 81 is 9. Look at what's outside, look at what's inside. It's still a 9 on the outside, it's still a 2 stuck in radical jail because he has no friends. Okay? So what we should have along the way with each of these, why am I blank? 81. What was that? 520 by 6 is 121. Okay, ideally I wish that you could do this. I wish that we could do this. We're not always going to be able to do this because we're not always familiar with the numbers.
It should be 16, and now that red down the bottom I should too.
What?
So it should
Oh,
be
that's a
16 and
2.
6.
That's a brownie point.
That's
Yeah.
2 brownie points. Should be 16.
Oh, I'm thinking of 5. I'm thinking of friggin' 5. No, it's the same problem. Okay.
Like 4 and 19 in there.
I was thinking 5 and 19 to make 95 instead of 90. Yeah. Better?
Yeah.
Okay. So, all right, with these, would y'all be cool with I can't combine them until they are actually like terms? So if I called that 9 by 7, 4 by 7, now it's a 3 square root of 7 plus a 2 square root of 7. 3 things plus 2 things is 5 things. Okay? Making sure that we remember stuff from way back when. So once I simplify the radicals, then I can start doing stuff with them. Okay. On the back side, it's the same thing, just more of it. When we get down here, okay, sometimes you luck out. A square root of a fraction is a fraction of square roots, which I can call the square root of 4 by 2 over the square root of 9, which I can say the square root of 4 is 2 and the square root of 9 is 3. So it would be 2 square root of 2 over 3. Okay? A square root of a fraction is a fraction of square roots. Sometimes that's easy peasy like this. Where one of them simplifies and the other doesn't. Ta-da, done. But this one, okay, this one becomes a problem. Because now I have 2 over 3 square root of 3. It's still considered not simplified. There's something called rationalizing denominators. It's kind of like that first boy-girl party. No radicals downstairs. They stir up the girls, give them bad ideas. Okay? I need him upstairs where I can keep an eye on him. So I multiply by the square root of 3 over the square root of 3. Okay? Why am I only multiplying by square root of 3? Why not 3 square root of 3?
You just need the radical together.
No radicals downstairs. He's okay. I know his dad. Like, he can stay down there. He's fine. Okay? Here, what is the square root of 3 times the square root of 3? The square root of 9, right? So this is 2 square root of 3. Square root of 3 and square root of 3 is square root of 9, but the square root of 9 is 3, and 3 times 3 is 9.
Whoa.
Okay? No radicals downstairs. All right? The square root of 3 is the only one that's not allowed down there. He looks a little shady. Okay? So, if I have square root of 3/5, that's the square root of 3 over square root of 5. Square root of 5 over square root of 5. Is the square root of... Can I simplify square root of 15?
Yes.
It breaks into 3 and 5, which are both prime. So just stays like that. Square root of 5 and square root of 5 is square root of 25, which is 5. It's important you do not try to reduce what's in radical land with what's outside of radical land. There are two different dimensions. There are two different universes. Inside the radical, it's like mathematical Vegas. What happens in radical land stays in radical land. Okay? You can't have someone who is in radical jail reducing with someone who's outside of radical jail.
Yep.
Okay? So, this is just practice, 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 and more practice with it.
Quick announcement as you're ending the room. You received notification from the superintendent that school will be let out early today due to the pending conditions. The 2 o'clock dismissal.
At 2 o'clock.
You're welcome to be.
Oh, we get to go right now?
Quiet!
If you ride the bus, we anticipate the buses will be here around 2:15. Just remain in common until then. You can go to class if you would like.
We have to do stuff to go to school.
2 o'clock dismissal will be a little bit later for us, obviously. School will be dismissed at 2.
No, it's just, we do a snow day, we do everything online.
Shut it.
Tonight's games against Belfouche will be canceled or postponed. We will not have the volleyball game.
It's cool, let's go home and relax. Let's go, baby.
Okay. Hey, y'all cool with this? If you know how to do it, hey! If you know how to do it, don't bother. If you need the practice, do some practice, take a picture of it, send it to me, and say, hey, did I do it right? Okay? Make sure you have 4 or 5 done. If we do not have school tomorrow, that just means our quiz will be on Thursday. Okay?
Hey, don't forget to add that